Students, in this class we can discuss about problems on series parallel circuit. Before starting problem, okay, just we can recall the important of series and parallel circuit. Series and parallel circuit. Suppose if the circuit there are number of elements are connected in series. What is the voltage? The total voltage is V and the current is I, because in the same branch there are so many elements are connected in series circuit. The current I is same throughout the circuit, whereas same circuit connected in parallel. We can assume now, if we are connecting this in the parallel, now we can assume in parallel circuit the voltage remains same. The voltage across each branch remains same, whereas the current I will get divided at the node. Okay, so the I will get divided into I1, I2 and I3. Okay, so what we can conclude, in series circuit voltage is nothing but the total voltage is the drop across individual element, that is if it is R1, if it is R2, if it is R3, drop across R1 is I into R1, drop across R2 is I into R2, and drop across R3 is I into R3. So it means that V is equal to drop across R1 is V1, drop across R2 is V2, drop across R3 is V3, whereas current remains same. I is equal to same throughout the circuit. So the voltage will get divided, the current remains same. Here the voltage remains same, the current will get divided in parallel circuit. Just you keep this in mind. Okay, so with this I will take one problem now. I will take the problem. The problem goes like this. Okay, I'll write the problem. Okay, the current here, the given current is at 6 ohm resistor is given, that is 2 amp. So the problem goes like this. The current in the 6 ohm, resistance in the given network is 2 amps. Okay, so I in 6 ohm resistor is 2 amps. So we have to determine all the branch currents and also the voltage in the circuit. This is the problem. Now here they are given, we don't know what is the total current I also, but they are given one current in that particular branch of 6 ohm resistor. Okay, by keeping this, we know current division rule, apply the current division rule and find the remaining currents and the voltage. Now I will apply the current division rule. Okay, so I want to calculate the current in I2. So this branch is unknown, therefore I will take, so the total current I, that is 2 is equal to I is total current. Okay, so we are finding the current in this 8 ohm. So I into 8 divided by 8 plus 6. If you simplify, you will get I is equal to 3.5 amps. So the I is nothing but 3.5 amps. So we already, the 2 amps current is given. Therefore, what is my I2? I2 is equal to I minus 2. So therefore, I2 is equal to 1.5 amps. So similarly, we can calculate what is I1 and what is I3. Okay, what is I1 and what is I3? We know total current I now. The total current I is 3.5 amps. Now keep it with this and find what is my I1. I1 is equal to total current I into resistance of the opposite branch, that is 20 divided by 20 plus 8. So what is I? 3.5 into 20 divided by 28. You will get I1 as 2.5 amps. Similarly, we can calculate I3. So what is my I3? I3 is equal to I minus I1. So what is I? 3.5 minus I1 is 2.5. So what is my I3? No need to apply now. We can calculate directly. I3 is equal to 1 amp. Now we have to calculate the voltage. So voltage is nothing but I into R. You can apply all the drops here. Okay. Now calculate 4 into I. Okay. Plus 6 into 2 plus 8 into I1 is equal to, if you consider that, so you will get around 46 volts. So it is a series circuit. So therefore, you can write 4 into I plus 6 into 2 plus 8 into I1. You simplify, you will get 46 volts as voltage. So with this, I will conclude this class. Thank you.